Alrighty, hello everybody, and welcome to the live OpenSSL webinar on getting started with OpenSSL with our very own OpenSSL engineer, Tomas Murat. My name is Kajal Sipkota, and I will be moderating this webinar. As a reminder to everybody, all attendees will be in listen-only mode. If you have any questions, then feel free to use the Q&A box or raise your hand to be unmuted if you'd like to ask the question live, as we will be hosting a question and answer session following this presentation. This webinar will also be recorded and made available on our YouTube channel shortly after the presentation. And I invite everyone to follow us on Twitter at OpenSSL _, as well as all of our other socials where we are also at OpenSSL _. And feel free to email us at feedback, that's FEEDBACK at openssl.org if you have any additional questions or comments. And as a reminder, the slides as well as the link to our YouTube channel will be emailed to everyone who registered for the webinar after in a follow-up email. So please stay tuned for that, and I will hand it off to Tomas for the presentation.
Okay. Hello, everyone. So let's start with this webinar. First, what we will talk about here. I will start with answering questions about what is OpenSSL and why would you want to use it. I will a little bit talk about history of OpenSSL. Then I will give overview of OpenSSL components, where to get the OpenSSL sources. I will show you how to build OpenSSL on Linux and Windows, and show some basic usage of the OpenSSL command line application. I will also tell you how to report errors and ask questions about OpenSSL. So what is OpenSSL? From our webpage, I took this phrase. It's a robust, commercial-grade, full-featured toolkit for general-purpose cryptography and secure communication. So I'm not going to introduce all these terms because I hope that people who are here on this webinar are really know at least some basics about cryptography and security. Yeah, this OpenSSL software, it has some crypto algorithm support. It supports all the current crypto algorithms. It does not yet support the future ones, those post-quantum ones, but that's we of course intend to change that in near future. But OpenSSL is also quite old software with some history, so it also has support for legacy crypto algorithms. It implements secure communication protocols for secure communication. That's TLS, GTLS, QUIC, and CMS. And it also has some implementation of the supporting infrastructure for those security protocols and other security-related things. So we have X509 certificate support. There is a CMP protocol, OCSP protocol support, and so on. So why would you want to use OpenSSL software? There are two main groups of OpenSSL users, and that's one for application developers. If you need to secure communications using one of those implemented protocols, or You need some data encryption and integrity protection for data. There might be also other direct uses of cryptographic algorithms to implement some custom protocols or custom special use cases. And there are also other specialized use cases for OpenSSL as a like application developer. And then there are like regular users and sysadmins, and they might be probably interested mainly in the OpenSSL application, which I will talk about later. And they can use it to, if they need to generate a key and certificate request for their website, for example, or they need to examine or verify a certificate that they obtained from some source. They can use it to protect their data with CMS. They can encrypt and decrypt messages in this CMS format. They can do, for example, hash fingerprint of data files. They can simply, there is a tool to simply encrypt data files. This application also supports testing TLS connections, and there are also other more specialized use cases. So what's the history of OpenSSL? This is quite old software, which was originally written by Eric Young and Tim Hudson as the SSL EAY software in late 1990s. The first OpenSSL release, because this is like the origin of the source code base, but the first release that was named OpenSSL was done on 23rd December 1998, and the version was 091C. That was like kind of start of this project. These are the major milestones. We had 098 version where the engine support was added, which are loadable crypto modules. Then there was 102 version, which was the first long-term support release. In 110 version, many structures were made opaque, so that's basically that was the first version where like quite big changes were needed from applications to use these versions. In 111 version, the TLS 1.3 support was added, and it was made a second LTS release. In 3.0 version, which was released like was 3 years ago, I think, there was a major refactoring with provider support and deprecation of low-level interfaces. What are the OpenSSL components? So on top of the stack, software stack, there is a OpenSSL command line application, or there can be third-party applications that use these two OpenSSL libraries. That's the libSSL and libcrypto. And we have also some engines that the libcrypto is using and providers. The libcrypto is kind of the central library of OpenSSL. It can be built as a shared or static library. It contains the implementation of crypto algorithms with some caveats because we are moving to providers. It contains all the necessary plumbing that's there for like handling those providers and loading them and things like that. And It has all this auxiliary support for these other things that are related to cryptography or secure protocols. That's the X509 CMS support, PKCS12 support for loading the PKCS12 files and saving them, and so on. It contains the default and base providers as built-in. That's why it also has implementation of crypto algorithms kind of built-in. The other library of OpenSSL is libSSL. It also can be built as shared or static library. It has implementation of TLS, DTLS, and QUIC protocols. And it calls to libcrypto for the crypto algorithm implementations, certificate verification, loading of keys, and other similar things. The OpenSSL command line application, which is named OpenSSL on POSIX-like systems and OpenSSL.exe on Windows. It's kind of Swiss Army tool for crypto-related things. It calls to libcrypto for the crypto algorithms, certificate operations, crypto key operations, CMS, OCSP, CMP, and many other things. And it calls to libSSL for testing for TLS and DTLS and QUIC, test client and server. Yeah, we don't yet have a QUIC server, but that's also going to change in the near future. Then we have those engines. These are basically like old concept, which is already deprecated, but they basically support third-party crypto algorithms, access to hardware crypto modules, but their main disadvantage over the new providers concept is that they are tightly coupled with libcrypto, which means that you cannot use engines across different versions of OpenSSL, like the same engine binary. You have to always build it against the same, again, the version of the OpenSSL that you are going to use it with. And providers, that's the new concept for the access to hardware crypto modules or new crypto algorithms, but also they provide also the default algorithm implementations that we have in OpenSSL. So every crypto algorithm that you use is going to some provider that's either built in, which is the default provider. It's a loadable module, which is the FIPS provider, or it can be a third-party provider. And it provides the new providers concept gives better isolation of the crypto implementations from libcrypto. So there is no problem to use a provider that's built with against one OpenSSL version and use it with OpenSSL that's a different version based on a different version, because the provider API is stable, possibly even across major versions. That was not yet decided, but most probably it will be kept stable. Yeah, the FIPS provider, for example, is created in a way that it's fully independent from libcrypto. It's statically linked to libcrypto, so it does not really, or it's statically linked from sources that are same as in the libcrypto, and that means that it's completely separate from. It does not load it on runtime. For further details on providers, please look at the providers overview webinar in our YouTube channel. Where to get the OpenSSL sources? So if we want to start using OpenSSL, we first need to get it from somewhere, and that's like simple answer is go to our webpage www.openssl.org/source. There are the latest releases from each currently maintained branches. There are also historic releases in source/old. Yeah, we release all new releases. We announce them on OpenSSL announce mailing list, which you could subscribe to if you want to get these announces. The source code tree is also available as the Git repository on github.com in OpenSSL/OpenSSL project. The releases are also uploaded there, so you can, if you for some reason prefer the GitHub downloading releases from github.com, you can download them as well there. Where to get pre-built OpenSSL binaries. So if you for some reason cannot build OpenSSL on your own, it is possible to get precompiled OpenSSL binaries from third-party providers. Look at the wiki.openssl.org binaries page for links. Of course, Linux distributions usually include OpenSSL binary packages, but they might be heavily patched for increased system integration. Typically, the Red Hat Enterprise Linux packages or Fedora packages are very heavily patched, less heavily currently than before, but still quite significantly. Yeah, we are considering to provide binaries ourselves in future, and we probably start with Windows binaries, but it's not yet fully decided and how they will look like and so on. So if I decide to build OpenSSL, I will give you some overview of how to do it on Linux and Windows. This webinar will show how to do it on Linux and Windows. Windows with Microsoft Visual C, because building on other POSIX-like platforms should be mostly the same as on Linux. MSys2 and Cygwin builds are not covered in this presentation, as there are some specifics, and it wouldn't be possible to get into such details here. For building OpenSSL, we need some prerequisites installed. Yeah, we need first download the source tarball, but we need tar and gzip to unpack the source tarball. We need Perl, which is used for build configuration, tests, and other minor things during the build. On Windows, we recommend Strawberry Perl. That's the version of Perl or build of Perl that we are running in the CI, so that's expected to work. Then you will need a C compiler, which could be GCC or CLang on Linux, and MSVC on Windows. For assembler support on Windows, you will need NASM. The minimal versions for Perl and NASM are mentioned in the install.md file. Actually, due to a recent regression in our releases, the minimal version of Perl on Windows must be 5.32, but that's only a recent regression for those releases that went out last month, and this will be fixed, or it's already fixed in the Git repository. So let's start with building on Linux. So I will unpack the tarball normal way by tar. I go into the OpenSSL 3.2.1 directory from the top of the tarball, unpack tarball, and I run configure /configure. This command, without any arguments, will do platform auto detection, and it will say something like configuring OpenSSL version 3.2.1 for target Linux x86-64, which is kind of default target on Linux 64-bit installation. Now let's talk more about the build configuration and about the configure script. The configure script is written in parallel, and it takes various arguments. It allows you to enable and disable some features. Some of the features are, or most of the features are enabled by default. So you don't need to use explicitly enable for those features, but you can switch them off by no dash feature. And for those features that are disabled by default, you need to use enable dash feature. The examples are here. Like there are some, for example, the FIPS module is not built by default because not everyone needs it. So you need to use enable dash FIPS for enabling FIPS module to be built. For example, there are some old legacy crypto algorithms that are no longer used built by default. So you need enable dash MD2 to build MD2. And you can switch off some other features which are enabled by default. So that's the no dash shared. Will switch off the building of shared libraries. No dash TLS1 will switch off the TLS1 version support, 1.0 version support. No dash EC2M will switch off the binary field elliptic curves support. There are, of course, many other options. So, after configure runs, you can use /config data pm -d to show the configuration details, such as the list of enabled and disabled features in your configuration. Let's talk about some options that you can pass to configure. You can use -- prefix with some directory to set the directory prefix for the installation. So default for Linux is /user/local. For Windows, it's program files /OpenSSL for on the C drive on Windows. Unfortunately, on Windows, the installation there is no way to like auto detect where the actual configured program files directory is placed. So it's always on the C drive here. You will need to explicitly change it if you need to put it elsewhere. You can use --OpenSSL dir directory to set the directory where the configuration files and the default certificate store is. This again on Linux, the default is /user/local/SSL and program files, common files, SSL on Windows on the C drive again. You can use --debug to build with debugging symbols and no optimization. Unrecognized options that begin with dash, plus, or slash are passed to the compiler as build flags. So you can pass things like defining some macros which can affect how the OpenSSL is built, some details, behavior of the built OpenSSL, and you can pass some optimization flags or warning flags to compiler and so on. And you can use the CC environment variable to override the compiler used. So you can use, by default on Linux, it will be GCC, but you can use CC equals clang, and that now clang will be used to compile OpenSSL. The important thing is that the last argument to configure should be the target platform for the build. Here are some examples like Linux-x86-64, Linux x86, Linux ARC64. These are Linux targets. For Windows, there are VC Win64A and VC Win32 for those most common Windows targets. Darwin 64-ARM64 is for Apple macOS, the current one. If the target platform is not specified, configure tries to auto-detect it, which should usually work correctly, at least on those commonly used platforms. But it will be needed for cross-compilation or non-default platforms like 32-bit build on 64-bit system. On this following link, there is a list of the platforms currently supported or like supported in the source code, but the level of platform support is varying based on whether there are systems in our CI and whether we have an expertise in the team. Those are like primary or secondary platforms are like most supported ones. For supporting other platforms, we depend on external users and contributors. Please also see the install.md file for further details on the configure script invocation. So we continue with building on Linux. You build it, we can use make-j8 to make a parallel build with 8 cores or threads. Make test will test it. That's very much recommended to do it because if you have some misconfiguration or some like breakage in your built environment, you can see some test failures, and of course it's not recommended to use OpenSSL build which doesn't pass tests. You can use v=1 for verbose test output. For example, in case you want to report an error in the build and you want some details from the tests. So if everything is all right, all tests are successful, result is pass, we can install it. We use make install for installation. You can use desdir equals some directory for the temporary install target directory. So that's for either if you need to pack the resulting install tree, or if you want to, for example, test the installation. Now let's talk somewhat about building on Windows. The prerequisites are basically the same. You need to ensure that you have tar, gzip, perl, and nasm on your path. You need to ensure that you can execute vcwars all.bat either by having it on your path or using the full path to execute it. That batch file is from the Visual C installation, and it will set up your command line in a way that all the appropriate binaries for the compiler and linker and make are on the path. So we first we run the vcwars all.bat with the selected target environment for the build. So if we want to build 64-bit Windows for 64-bit Windows on the normal Intel AMD processors, you use vcwars all.bat AMD64. Then we unpack the tarball, change directory into the OpenSSL 3.2.1. That's the top level directory from the tarball, and we configure the build. That's important to know that the toolchain is set with vcwars all.bat must match the target here. So if we have AMD64 as the environment, we should use perl configure bc-win64a to configure for the 64-bit Windows build. When you want to build both 32 and 64-bit builds, it is critically important to clean the source tree of build artifacts between the builds, like with and makes clean and reconfigure, because it's otherwise the build will fail because of mismatch of those pre-built things. After configuring, we can build compile and link the OpenSSL library with nmake. Unfortunately, on Windows, there is no parallel make support. So please be patient. It takes much longer time than on Linux. So then you can test it again with nmake test. The b equals 1 is the same as on Linux for verbose test output. You can also use tests. That's was possible, of course, on Linux as well. Tests, by using tests, you can select some particular test that you want to run. If you, for example, have some failing test and the output is not clear, from the default output of nmake test is not clear what was the about the failure, it's useful to use b equals 1 and select the test that was failing, because otherwise the output will be too verbose and it will be probably hard to find the exact place where the failure was happening. Again, if everything is okay, all tests are successful, a result is pass, and we can install it. We can again use this there for install target directory, the temporary installation. For further reading on installation, I would recommend looking at the initial OpenSSL guide manual that has also some links, further links to go through. The detailed installation instructions are in install.md file in the source tree. The most important changes in releases are covered in a news.md file in the source tree, and details notes about individual platforms are in notes-something.md in the source tree as well. So we have the software installed. So what we can do with it as users, we can use the OpenSSL command line application, which is as I said, this is kind of Swiss Army tool for crypto-related things. Here is the list of the most useful commands that we have there. The gen RSA ECParam commands are generating RSA and ECDSA keys. Then we have RSA, similar RSA and EC commands that can be used to examine and convert RSA and ECDSA keys. And then we have also like the SPKey param, genPkey and pkey utilities that are key type agnostic. They with the provider support, they even allow to, like, if you have third-party provider that provides new algorithms that OpenSSL does not implement by itself, those utilities allow you to generate keys and examine them and so on. The one of those like most useful commands is rec, which is for generating and inspecting certificate requests. X509 and verify commands are for inspecting, signing, and verifying certificates. S client and S server are test TLS and DTLS client on servers, and in the recent version, the client also supports Quick in a kind of rudimentary debugging way. It's not a full-featured Quick client because that would require like multiple streams and so on, which is not in like the Quick client supports multiple streams, but not the S client tool. The speed command can be used to test speed of the implemented algorithms, especially when you can compare the various versions one against other. Further useful commands are digest, which is for computing file digest with a specified hash algorithm. ENC, that's a simple file encryption utility. It's no longer, I would say, like modern utility because it does not really support proper AAD and things like that, but AAD algorithms and similar modern things, but it can be handy if you need just simply encrypt some file. There is a FIPS install command, which is used when installing FIPS provider module configuration. There is a list command to print various lists, such as digest algorithms is listed with list. With dash digest algorithms, providers are listed with dash providers, but there are like many other things that you can list with this tool. PKCS12 command can be used to create PKCS12 files, or the other way, to extract keys and certificates from existing PKCS12 file. And there are many other commands. One thing to note is that the command options are always prefixed with a single dash character, although they are kind of like long commands. we don't the command line application does not conform to the like current trends with dash dash options for long options. You can use for the list command. You can, for example, use OpenSSL list -h to list all possible lists, and it's similar for other such commands that you can use. Basically, OpenSSL command -h to print out some more detailed help for those commands. So we will now look at some examples of the OpenSSL application use. I have this only for Linux, but on Windows it would be very similar. So if we install the OpenSSL build into directories on the system where the linker or dynamic loader will normally load the libraries from, and the path and the binary is installed in a path that is contained already on your normal path, you won't need those two export commands I have here. But if I've created, for example, I used desdir to install these the binaries and libraries into some temporary installation. I need to use export commands to override the path from which the libraries are loaded. That's for the export ld library path, and the path from where binaries are executed. So I do this, then if I run OpenSSL command, it will list all commands that I can use. So you can see some standard commands, SM1 parse, CA, ciphers, CMP, and so on, so on. OpenSSL-v will print the version of the application and library it uses. That's very useful to do to verify that I'm actually running the OpenSSL tool from the build I did just before, and that the library used by this application is also the correct one. So the two versions should be basically the same. Otherwise, either the library or the application is probably not the one we have just built. And it, of course, needs to be the version that we built. Yeah. So let's show some examples of how to use OpenSSL application. So one first example I have here is how to generate a key. We can use the OpenSSL list -public key algorithms to list algorithms that you can use for key generation. So we can see here some legacy. That's not interesting here, but we can see also there is some provided algorithms. And those key managers, we see some things like OpenSSL RSA implementation with some IDs. And there is the at default, which means that this implementation is from the default provider. Those object ID names are not that much interesting, but there is RSA, which is like the primary name of the algorithm. And we can use OpenSSL gen pkey -algorithm RSA -h to see what we can specify for generating RSA keys. And there is some output, and also the possible p-key opt arguments are bits, colon uint, primes uint, uint. So what are these parameters of the algorithm? Bits is the length of the key, basically, and primes is number of primes that you can that the key is generated with. That's kind of advanced usage, so not needed to change. And E and the default is basically 2 primes, which is the common thing for RSA keys. And E, that's a little bit less advanced usage, but also does not need to be changed from the default unless you have some very special requirements. The default value is the most common one and fastest one. That's also secure, and that's 65,537, which is the Fermat number 4. So we generate, we want to generate a key that's 4096 bit long, and with the default number of primes and e-value, and the key will be unencrypted. We can use -AS128 CBC, for example, as the name of the algorithm to encrypt it with, but we don't do it here. In this example, we run OpenSSL gen p-key dash algorithm RSA p-key opt bits colon 4096 for the bits dash out RSA key PEM. This will save the generated key into the RSA dash key PEM file. And yeah, after a few seconds, this key will be generated, and we can look at what's in this PEM file. There will be some base 64 gibberish between begin private key and private key markers. Other key types, such as ECDSA or ECKs, will have different possible p-key opt params. For example, for EC, these will be group string, encoding string, and many other parameters. So what we can do with key? Usually we want to generate a certificate request. For that, we have this REQ application, and we can use OpenSSL REQ-H to look at the options that it has. There will be like many options. The most useful for us at this point are -new, which basically means that we will generate a new request and not examine some existing one. -key and value here is the file where we have the key which we want to use for this new request, and -out output file is for specification of output file where the request will be placed. So we can try OpenSSL REQ -new -key RSA key PEM out cert -REQ .pem, and we will see probably some error. At least that's what I saw, because I did not install really the OpenSSL into user local SSL, but I used this there. So there was no OpenSSL.conf file in that place. So we have some short intermezzo about OpenSSL error reporting here. The OpenSSL library provides an error queue, And so there can be multiple errors, as we can see here. We have actually 2 errors here. And let's look at what those strange things here mean. So the first value is threaded. That's not really interesting, I think, usually. But the error code can be interesting in case it, like, for example, there is some problem with the conversion from the error code into those text error reasons. So the next part is a subsystem, which can be system library for errors that come from the libc, basically. Or it can be, for example, bioroutines in case of the subsystem of libcrypto or libSSL. Then there is the source code function, in our case, bio new file, and error reasons, which can be basically from, in case of system library errors, it's a text from the error error conversion. But in case of native errors from libcrypto, this can be some short description of the error that we encountered. Then there is a file of the source code and line of the source code where the error was reported. And there can be also some additional description there, which does not need to be there always. So we continue with generating certificate requests. We need to set the path to the OpenSSL config file that we actually installed. So the error happened because temporary desdir was used. So we set path to the config file with export OpenSSL_conf. And now we can really generate the certificate request. After you run this command, there will be some questions asked about the basically about the name or distinguished name parts from the certificate. So I can enter, for example, CZ for the country name instead of the default AU. And then I can look at the resulting certificate request PEM file, which starts with begin certificate request, and then there is some base64 encoded data. So we can also, I wanted also to cover the basic file formats here. OpenSSL supports loading or writing of 2 basic file formats, and there are DAR and PEM. The DAR format is binary encoding of ASN1 structures, which are specific per the type of the stored data. PEM, what we see here, they are the default format, and they are base64 encodings of the DAR binary blobs. And they start with begin type and end with end type. So they provide some it's possible to look at them and see what the PEM data is of which type. So let's say we have some key file and we want to examine them, that data. So we can use OpenSSL pkey-text-noout. That's for no, like, so we tell the pkey command to output just the textual information that could be for like end user, or it could be readable by end user, and we don't output basically the copy of the key. And dash in specifies the input key file. And we will see that we have some private key, which is 4096 bits and 2 primes and there will be some modulus and some exponent and so on. We can examine a request file with OpenSSL rec command. Again, we use -text, -noout, and we input the certrec.pem file, and we will see that this is a certificate request, and the data version is 1. That's default, or there is no other version for certificate requests, and there will be some subject and so on. So for further reading on the usage of the OpenSSL application, we have manual pages for all supported commands. They are in our web pages, in docs and man. There is also configuration file format manual for this OpenSSL.conf config file that we shortly mentioned before. And there is also a very important page about environment variables that are recognized by OpenSSL. As a final thing I wanted to cover is how to report bugs and ask questions about OpenSSL. The primary channel for bug reports on OpenSSL is the GitHub project. For bugs and feature requests, please open an issue on this github.com OpenSSL/OpenSSL. And for questions, please open a Q&A discussion thread again on the same project. Please look for existing issues or discussion threads if you are reporting an issue, because it could be already covered. If you, for some reason, cannot use GitHub, you can use users' mailing list to post questions, users' questions. We have also, of course, commercial support, which is information. There is information about it on the web page as well. So thank you for listening.
If you have, again, any other questions or comments, you can either email us at feedback, that's FEEDBACK @openssl.org, and we'll be happy to answer. Or you can go to our support page on GitHub and open up an issue, and we'll be happy to answer there as well. Thank you, Tomas, Matt, Hugo, and Neil for attending this webinar. Thank you, Tomas, for a wonderful presentation. Thank you, everybody else, for attending this webinar. If you have, again, any questions or comments, please contact us. This webinar is being recorded and will be made available on our YouTube channel after the presentation. And you will be emailed a follow-up link with the slide deck, as well as link to our YouTube channel following this presentation. Thank you so much, and I hope everyone has a fantastic rest of their day.
Thank you, everyone.
Thank you. Bye.
Bye-bye.